Good evening. Thank you for joining us. I'm Dr. Robert Golden. I serve as the Dean of the University of Wisconsin School of Medicine and Public Health. I also serve as the chair of the board of UW Health, the university's academic health system. I work very closely with my partner, Dr. Alan Kaplan, who is the CEO of UW Health. During tonight's Wisconsin Medicine presentation, we're turning our focus on Alzheimer's disease. If you've been able to join us for our prior installations, you know that our hope is to use this Wisconsin Medicine Livestream platform to share with you some of the amazing emerging breakthroughs that come out as a consequence of the wonderful partnership between UW Health and the UW School of Medicine and Public Health. Alzheimer's disease is devastating. It destroys memories. It disrupts and hurts families in terrible ways. Do you know that among the 10 most deadly diseases in our country, it's the only one that cannot be prevented or cured at this time? But there is hope. The UW Initiative to End Alzheimer's, a wonderful collaboration between our Wisconsin Alzheimer's Disease Research Center and our Wisconsin Alzheimer's Institute, is committed to developing a cure. To start us off tonight, it's a pleasure to introduce you to Dr. Sanjay Asthana. Dr. Asthana is the inaugural director of the Wisconsin Alzheimer's Disease Research Center, what we call the ADRC. And he's also an internationally renowned researcher and leader in the field of Alzheimer's disease. In addition to his work in directing the ADRC, Dr. Asthana holds several other major leadership positions, both in our school and in our health system, including service as the Associate Dean of Gerontology, the Director of the Geriatric Research Education and Clinical Center at the William Middleton Veterans Administration Hospital, and the Director of the NIH-funded Biology of Aging and Age-Related Diseases training grant. Dr. Asthana sees patients in the UW Health Memory Assessment Clinic, specializing in assessing and diagnosing patients with Alzheimer's disease and related dementias. Welcome, Dr. Asthana.
Thank you, Dean Golden. Good evening, everyone. It gives me real pleasure to describe the University of Wisconsin Alzheimer's disease program to you all. Next, Alzheimer's is the most common cause of dementia and currently affects nearly 6 million Americans. The projections are that unless we find an effective treatment or perhaps a cure for Alzheimer's disease, nearly 14 million Americans will have the disease by 2050. Alzheimer's is a costly disease and places enormous financial burden on patients, their families, and the US healthcare system at large. Unfortunately, Alzheimer's is a lethal disease and is the 6th leading cause of death in the US. In fact, Alzheimer's is the only disease that among the top 10 causes of death has an increasing death rate. Next. The UW Alzheimer's program is world-renowned. It is built on 2 pillars: the Wisconsin Alzheimer's Disease Research Center, or the ADRC, and the Wisconsin Alzheimer's Institute, or the WAI. The ADRC is one of only 31 centers of excellence funded by NIH, and it sponsors cutting-edge research across all stages of Alzheimer's disease. It also supports engagement and research training. In fact, it is training the next generation of scientists here at UW. The WAI is closely tied to the public health missions of the state of Wisconsin. It supports cutting-edge research through the renowned Wisconsin Registry for Alzheimer's Prevention, or DRAP. It also supports public education, outreach, and public health. Between the ADRC and the WAI, the UW program supports the largest and the longest followed cohort of people who are in their middle age and at increased risk for Alzheimer's disease. The research data that have come out of this cohort have resulted in the publication of over 800 papers in the past decade, and many of these papers have added original information to the field of Alzheimer's research. Both the ADRC and WAI receive funding from the NIH and many other sources. Next. The UW program takes a holistic approach to address a complex disease like Alzheimer's disease. The scope of research at UW spans all the way from molecular biology to animal research to patient care research to community-based research. All the research findings that come out of these studies are shared and disseminated widely to numerous clinicians and practitioners across the state of Wisconsin, throughout the United States, and worldwide. The mission is to improve and provide state-of-the-art care to tens of millions of people who are suffering from Alzheimer's worldwide. Next. The UW Alzheimer's program truly embodies the Wisconsin idea. That is, any research or work that is done at UW-Madison should cross the boundaries of the university, spread throughout the state of Wisconsin, and then across the country, and then worldwide. In fact, at any one time, the UW Alzheimer's program has over 100 active collaborations locally, nationally, and internationally. Among some of the international collaborations include studies in Spain, Germany, Australia, Sweden, and Israel. Next. The UW program has distinctive strengths in 4 areas of research, and these strengths distinguish this program from any other program in the country. The first area of strength relates to early detection of Alzheimer's disease. Dr. Sterling Johnson is a world-renowned scientist, and he's using cutting-edge brain imaging scans, examination of the spinal fluid, and using some of the emerging, exciting, simple blood tests that could be used to detect and diagnose Alzheimer's early. The second area of strength relates to studies that are examining how various medical diseases that are very common in people with dementia, like high blood pressure or heart disease or diabetes, how these diseases affect the diagnosis and treatment of Alzheimer's disease. Dr. Cindy Carlson is widely acclaimed in this area of research. She'll also discuss how various social factors such as poverty or education or income, or perhaps living in a poor neighborhood, might increase the risk for Alzheimer's disease. The third area of research relates to health equity and disparity. Dr. Carrie Gleason is nationally renowned for her studies that are examining how Alzheimer's might differ between various races and ethnicities. And finally, the Wisconsin ADRC is the first center in the United States to launch an innovative program in how to improve patient care and change the clinical practice. Dr. Amy Kind is internationally renowned in this area of research, and she has published numerous high-profile papers suggesting how patient care can be improved and how we can change clinical practice. Next. It is quite clear that the only way we can win Alzheimer's is through cutting-edge research. We are very fortunate that we have an outstanding interdisciplinary team of over 120 scientists, trainees, and staff that help us conduct Alzheimer's research. We are extremely grateful to over 2,000 people who have enrolled in our research studies, helping us generate novel data. It is our sincere and collective wish that one day we'll find a cure for Alzheimer's disease and eradicate this devastating illness from the globe. With that, I'll hand over the presentation to Dean Golden. Thank you very much.
Thank you so much, Sanjay. You've done a wonderful job of setting the table for the subsequent courses that are now going to be served. And first up, it's a pleasure to introduce Dr. Sterling Johnson. Dr. Johnson is the Gene R. Finley Professor of Geriatrics and Gerontology in our Department of Medicine's Division of Geriatrics and Gerontology. Sterling serves as the Associate Director and the Biomarker Core Leader in the Wisconsin's Alzheimer's Disease Research Center, And he's also the associate director of the other pillar, the Wisconsin Alzheimer's Institute. He also leads the Wisconsin Registry for Alzheimer's Prevention, or WRAP, which is an amazing longitudinal cohort study of more than 1,500 people at varying stages of risk and varying levels of risk for Alzheimer's disease. In the WRAP study, he is investigating the many risk factors for cognitive decline, including lifestyle as well as genetics. Welcome, Dr. Johnson.
Thank you, Dr. Golden. It's a pleasure to be here tonight and talk to each of you about new breakthroughs in early detection and prevention of Alzheimer's disease. This is really a fast-moving field, and it's exciting to be a part of it, and also to show you some of the new things that we are onto and that we're following up with research. Let's go to the next slide. Our goals are to identify Alzheimer's before its symptoms do. And you think of Alzheimer's as affecting the brain. That means we got to get in and study the brain, and we do this with brain imaging in detail. We also want to identify genetics and health and lifestyle factors that prevent this disease from progressing to dementia. And as already been mentioned here, we study the Wisconsin Registry for Alzheimer's Prevention, or WRAP, and the ADRC clinical core to look at this. And why do we study these cohorts? Because they're enriched they have people in them who have a parent with Alzheimer's disease or had a parent with Alzheimer's disease in some cases. And these are individuals who've seen this disease up close and personal. Let's go to the next slide. And so our participants are quite dedicated. They understand this disease, and they've seen how it impacts lives. And what I'm showing you here is how this disease looks under a microscope. Here in the middle of the screen, we see amyloid plaques and neurofibrillary tangles. The plaques are composed of amyloid proteins that aggregate together, and the tangles are composed of a protein called tau that also aggregates together, and it does this inside neurons or inside of brain cells. Well, fortunately, we do not any longer have to wait till a person passes away in order to see definitively if Alzheimer's disease is present. We can use some sophisticated new forms of brain imaging called amyloid brain imaging and also tau imaging. And some examples of those are shown here on the sides of the image, the sides of the slide. Let's go to the next slide. We can also do this with spinal fluid. I mentioned these are proteins that are in the brain that we can image. There's this and other proteins, amyloid protein and tau protein and hundreds of others are in the spinal fluid. And the spinal fluid bathes the brain, and it's something that can be accessed from the lower back. And we can get this fluid and look at these proteins and many others that might give us clues about brain health and about the early signs of Alzheimer's disease. Next slide. Soon, we hope it will be possible to use blood as well. Although I must say, we've got over 800 people who have courageously provided spinal fluid using a procedure like what you just saw. I think many more of our participants will be happy to provide blood instead of the spinal fluid tests to understand the proteins that change in Alzheimer's disease. And we're excited that the field is really moving in this direction, and some important recent discoveries have been made that suggest to us that it's going to be feasible in the very near future to look at these protein levels in the blood for various stages of Alzheimer's disease. Let's go on to the next one. So let's talk now about how this disease progresses and how we know that it exists. Again, we're trying to identify this disease before it starts. And here's how it starts. We think it starts with amyloid protein buildup in the brain, and we can image that. And there's an example of that in the upper left. And then if we follow the arrow down, the next thing that happens is the tangles. And these, as you remember, are composed of tau proteins. And then we have a loss of the nerve cells and eventually mild impairment and then subsequently dementia. And dementia just means that a person is no longer able to function in the world the way that they used to function, and they're impaired. And I'm showing you some examples of images from a person from our study who has dementia, and you can see their MRI and amyloid and tau scans there on the lower right. And the images that are surrounding that large arrow are from a healthy individual who does not have symptoms. What we need to know is how long it's going to take for a person like that to eventually develop symptoms, so that we can figure out how long we have to try and slow it down. We think that this takes about 20 years. And let's go to the next slide. How do we know that it takes 20 years? It's because many of our participants have been involved with amyloid and tau PET scans, these images that I've been talking about. And we've been doing this since 2010, and some people have as many as 4 or 5 of these scans with us. And the picture here on the left is a bunch of people with amyloid imaging. If there's a line, that means a person had more than one. If there's a single dot, that's from an individual who's had a single PET scan. But what you'll notice from this is that those lines of accumulation, those red lines above the dotted line threshold, they're all pretty much going at the same pace. They're all rising at the same rate. What differs is the age of onset, as you can see. But with some new computing algorithms, we've been able to identify the age of onset, or basically when an individual has crossed that dotted line threshold. And if we line people up based on when they cross that dotted line threshold, we see the image here on the right. And what all these lines mean is that we can detect Alzheimer's disease, or at least the amyloid protein levels in Alzheimer's disease, and we can detect basically when these proteins are starting. This is a major breakthrough for us because this allows us to test those other things I was talking about, like what it is that we can do to slow this disease down or prevent it. Let's go to the next slide. So what I've talked about so far is that this disease begins many years before its symptoms, and that we now have the tools we need to study how it develops and what might slow it down. And this also means we have the tools to measure whether an intervention is effective at preventing this disease. Next slide. Well, we're going to talk tonight a little bit more about some of these things that might slow down dementia or prevent this particular form of dementia, Alzheimer's disease. You might have seen in the news articles and news media attention drawn towards these kinds of things, with a suggestion that these things will slow down dementia or prevent Alzheimer's. These are things we're actually studying quite intensively here at the University of Wisconsin. They're being studied at many other places around the world as well. Does high blood pressure slow down dementia? We think it probably does to some degree, and it's whether it's causing a slowdown in amyloid buildup, these protein buildups, or whether it's just conferring a sense of brain health, a state of brain health to the individual, is something that we're actively studying. And my colleague, Dr. Carlson, will talk about that in a few minutes. But I just want to dwell on one point on the next slide here. And this is results from a brand new clinical trial that the field is still learning about, and was first presented back last winter in December. This is from Biogen, and it's called the EMERGE study. And in this study, they used a experimental drug called aducanumab, and they did this in people with mild impairment, mild cognitive impairment, or mild dementia. And they looked at how the disease progressed, at how their symptoms progressed. And what you see here in the gray line are people who had the placebo, and in the purple line, people who had the high dose of aducanumab. And what we're seeing is that the people with the high dose of the drug had a slowdown in their symptoms. And on the next slide, I want to mention that this drug also lowered their amyloid levels on a PET scan. It lowered it to normal levels. And so this is quite remarkable. We are cautiously optimistic about this experimental drug. The FDA is evaluating this drug now for approval. And whether or not they approve it as is or want further study, that's up to the FDA to decide. But we think that this is grounds for being optimistic. And even if this drug is not approved, there's many other in this class of medicines that are in clinical trials right now. And we're hopeful that in the very near future, there'll be a drug that removes amyloid from the brain and slows down these symptoms. Let's go to the last slide I think I have here. And that is to summarize what I've said, and that is that we can detect this disease before its symptoms begin. And we think this silent phase of Alzheimer's is about 20 years in duration, and we think this is the time to intervene. And it's quite possible that we'll be able to detect this disease in blood in the very near future. And this is important because it's going to help us identify the right people for clinical trials or for prevention treatment as these treatments become available. So we're optimistic about the state of the field right now and the state of treatment in this field. We're also really encouraged about the work that's happening in lifestyle and health factors that might lower the risk of dementia. And my colleague, Dr. Carlson, will be talking about that in the next segment. Dean Golden, I'll turn it back to you.
Thank you so much, Sterling. That was a wonderful summary of how our investment in learning about the neurobiology and the natural course points us in the direction of potentially new approaches to treatment and prevention. And it also sets the stage beautifully for the next presentation from Dr. Cindy Carlson. Dr. Carlson is the Lewis A. Holland Senior Endowed Professor in Alzheimer's disease within the Division of Geriatrics and Gerontology in our Department of Medicine. She's the director of the Wisconsin Alzheimer's Institute, the clinical core leader and a co-leader of the biomedical core in the Wisconsin Alzheimer's Disease Research Center, and a recipient of the University of Wisconsin Vilas Distinguished Achievement Professorship. Dr. Carlson is a member of the prestigious National Institutes of Health Alzheimer's Disease Center's Clinical Core Steering Committee and Clinical Task Force, and she also chairs several NIH research review committees. Cindy is an outstanding geriatrician who treats veterans with dementia and memory issues at the Middleton Memorial Veterans Hospital right here in Madison, and she's also the co-director of the Memory Assessment Clinic there as well. So please join me in welcoming Dr. Cindy Carlson.
Thank you, Dean Golden. It's an honor to be here today and to talk with you about some of our team's work on understanding how the impact of underlying diseases affects Alzheimer's disease risk. Next slide. So as Dr. Johnson set the stage, Alzheimer's disease treatment and prevention has chiefly been targeted at amyloid. So again, the amyloid are these proteins that build up and clump together in the brain, and then those clumps irritate the nerve cells nearby. So you can see in this diagram, the nerve cells in the brain are represented by the purple cells and then the brown clumps of amyloid building up and causing damage. The risk factors that we commonly think of with Alzheimer's disease, things like increasing age, family history of Alzheimer's, genetic risk factors such as apolipoprotein E4 or ApoE4, and Down syndrome. Many of these risk factors work through increasing amyloid deposition in the brain. And again, these are risk factors we can't really do much about. But if you go to the next slide, but we have found that there are certain underlying diseases and social factors that also increase risk for Alzheimer's. And so things like have been mentioned, high blood pressure, diabetes, cholesterol, so things we usually think about with cardiovascular risk, but also things like our sleep, traumatic brain injury, social determinants of health, so what stressors we're exposed to, poverty, lack of access to resources and quality education, and then also depression and stress. So the good news is that these are things that we can do something about. Next slide. So the contributing factors, these contributing factors may impact brain health in different ways. So Dr. Johnson's mentioned that the main cause of Alzheimer's is, from our understanding currently, is these amyloid plaques being deposited in the brain. So if you look at the figure on the left, this is a cross-section through the brain as if you're looking down from on top of the brain, so kind of viewing it from above. And some of you may have heard of people talking about gray matter and white matter in the brain. Well, the gray matter is composed chiefly of the nerve cells or the brain cells, the main bodies of those. And so it makes the tissue look more gray. So you can see in the figure, kind of the ribbon around the edge of the brain has these gray matter. But there's also really important tracts in the brain that connect the nerve cells to each other. And so if you look at the right, I have a wire with a coating on there. And excuse me, if there are electricians in the audience, I'm not very savvy with this. But again, the nerve cells, the gray matter is kind of like the ends of the wire where they come out and make connections. There's also this white coating that's made up of cholesterol in the brain that coats the nerve cells in these connection tracts, and that's what's called a white matter. And the cholesterol makes it look like it's white on the image there. And so we know that these different risk factors, some increased amyloid deposition and some directly target the cells, but others affect the white matter. So if a mouse gnaws through the coating on this electrical wire, it's not going to conduct the signals as well. And similarly, if the white matter is degraded, then those nerve cells don't function as well, and it affects thinking abilities. Next slide. So here's Bucky, and Bucky is loving his brain in the middle picture here. Bucky came to our program. This is pre-COVID. That's why he doesn't have his mask on. But Bucky's doing some things to really help improve his brain health. So you can see he's seeking out educational opportunities. He's getting his rest. He's making sure he has good cardiovascular health. And he's taking some action and starting some exercise programs. Next slide. But if, as many of you maybe I'm just the only pessimist here, but sometimes I think, really, how much of a difference does this make? Until we get these breakthrough amyloid therapies, are we really going to be able to make a difference by modifying these underlying diseases and social factors? Well, this was a study that was published recently that looked at these top 7 factors that could be modifiable. So diabetes, blood pressure in midlife, obesity, physical activity, smoking, low educational attainment, depression. And what they did was they looked and said, if we reduced the prevalence of each of these conditions by, let's say, 10% per decade, so 10% number of people, 10% of the population would have less diabetes, each of these factors, how would that affect Alzheimer's risk? And you can see by the blue line, with a 10% reduction, by 2050, 10% of all Alzheimer's cases would have been reduced. And if you reduce these risk factors by 20% per decade, then close to between 15 to 20% of all Alzheimer's cases could be prevented. So think about that, 6 million people with Alzheimer's, a 20% reduction, that's a lot of people who have improved cognition. So next slide. So what our team's trying to do is, first of all, to learn how do these medical problems and social factors influence the brain? Is it through amyloid? Is it through affecting those white matter tract? And so our team is studying vascular risk factors. We have studies looking at sleep, exercise, and even our gut health, which we know can affect our immune system and other factors as well in our health. We also have team members who are looking at social determinants of health. So Dr. Kind has looked at neighborhood disadvantage, and the map in the middle of the slide shows areas of the state that are red, showing more disadvantage, such as more poverty, lack of access to resources, and then the blue areas with more access to resources or less disadvantage. Other factors such as education and stress, and these come into play too as we think about health equity and different prevalence of Alzheimer's disease in different populations, including African Americans, Native Americans, and Latino populations. Next slide. So then our team not only is looking at how these factors relate to these various underlying medical problems, but also how can we target these different potential mechanisms. So for example, our team is looking at anti-amyloid therapies, of course, so we're wanting to make sure that we're looking at this both in people who already have Alzheimer's, but also people who are at risk for Alzheimer's. And then also looking at other factors. So can we look at statin medications, fish oil? Can we look at other microbiome supplements and exercise in different populations to see if we target amyloid and other potential mechanisms as well? So again, our team is really looking at all the different factors and trying to work at ways to prevent this disease. Next slide. And being at the only, at least the first combined School of Medicine and Public Health, we want to make sure that these discoveries get out to our rural populations, our African American communities, our Native American communities, our Latino communities throughout the state. So our team has, through the Alzheimer's Disease Research Center and through our Wisconsin Alzheimer's Institute, we have outreach, education, and service to communities throughout the state. So we train primary care clinicians and some subspecialty care clinicians in how to provide good dementia care, and have over 40 clinics throughout the state that we help support and train to make sure they know about these cutting edge therapies. We also have programs to help make a difference in these public health measures by helping people learn computer classes or learning how to eat healthy, helping them to learn about controlling their blood pressure and thinking about how they could reduce their risk. So again, our program, and I'm so thankful to be a part of this because we have a team that are really committed to finding ways to prevent the disease, to caring for people who have the disease, and to make sure that these discoveries are shared throughout our state. And so I'm really honored to work with our team and our participants, over 2,000 participants in our studies, to help us make these discoveries. So I'll stop there and turn it back to Dean Golden. Thank you.
Well, thank you so much, Cindy. I think that portfolio of amazing work by your team really personifies what it means to be a School of Medicine and Public Health. And I love the focus on both new medical approaches to the disease, but also disease prevention and health promotion approaches. Wonderful bit of work there, and look forward to the next chapters. Now, it's a pleasure to introduce our closing speaker for the evening, Dr. Carrie Gleason. Dr. Gleason is an associate professor in our department's division of geriatrics and gerontology, and also an affiliate faculty member in the Department of Rehabilitation Psychology and Special Education in the UW School of Education. She leads the Inclusion of Underrepresented Groups core at the Wisconsin Alzheimer's Disease Research Center, and also serves on the board of directors for the Alzheimer's and Dementia Alliance of Wisconsin. Now, in 2018, Dr. Gleason received a Veterans Administration Strategic Priority Team Award for unbelievable leadership in establishing the first ever Dementia Friendly VA hospital in the US, which has become a model now throughout the country. She is nationally renowned for her research in health disparities and in preclinical biomarkers of Alzheimer's disease in African Americans and in Native Americans who are at risk for dementia, and also is establishing two of the largest cohorts of participants from African American and Native American communities in studies examining how Alzheimer's disease differs between various races and ethnicities. So welcome, Dr. Gleason.
Thank you, Dean Golden. So I just want to start by thanking the organizers and Dean Golden for the opportunity to be here this evening and to talk to the audience about some topics that are particularly close to my heart. So looking at what were our successes and making sure that we are recruiting a diverse and inclusive Alzheimer's disease cohort. You've heard from my colleagues about our efforts to prevent the disease as well as our efforts to develop biomarkers. We're making sure, right by partnering with communities right here in Wisconsin, that these treatments and preventions and biomarkers are inclusive, in particular with our African American and Native American partnerships. Next slide, please. So you might be asking why this is important. Isn't the disease the same in every group, regardless of race or ethnicity? Even if that's true, I would argue that it's a matter of justice, that those who carry the greatest burden of the disease should also be part of the treatment and prevention efforts to make sure that what we are developing will work with different groups. So these are data from a recent study that showed compared to the lowest risk group, Asian Americans, African Americans were 73% higher risk for Alzheimer's disease, and American Indians 43%. Next slide, please. This is the same data broken down by age group, and you can see in almost every single age category, African Americans and Native Americans are the group at greatest risk for the disease. So again, advocating that the groups that carry the greatest burden are part of the story of our efforts to prevent or cure the disease. Next slide, please. So how are we doing as a program? So I can highlight how our programs combined have enrolled 343 African Americans, and this is primarily from cohorts in Milwaukee and in Madison. And we've enrolled 64 American Indians. And again, these are combined across all of our affiliated studies, including my R01 of African Americans fighting Alzheimer's disease in midlife. Next slide, please. So to put that in context, I turn now to the data that was used to develop or get approved by the FDA all of our current treatments for Alzheimer's disease. This includes donepezil, rivastigmine, galantamine, and memantine. All of those are approved medications. When we look at the studies that were used to get approval for those drugs, there were 49 included in the systemic review. Only 29 of those 49 actually reported race. And of those, the total number of participants are over 21,000 individuals. Those are predominantly white sample that was included for the approval of these drugs, 78%. 13% were Asian. Only 1% were Black, and less than 1% were from an indigenous population. So the map up in the upper right corner shows where these studies were done. So this includes the most of the data came from Australia and North America and Europe. So those, certainly there are countries that include a large indigenous population, such as Australia and Canada and North America, or excuse me, America. Next slide, please. So bringing it closer to home, how do we do compared to other centers? Dr. Asana mentioned that we are one of 30 centers throughout the country. Those data collected at the centers are all compiled by the National Alzheimer's Coordinating Center in Seattle. Altogether, there are close to 43,000 individuals enrolled in our centers across the country. Of those, 79% are white. Again, there's an overrepresentation of the white population. 12% are Black or African American. So we are aligned with national data in terms of the population for Black or African American, with over 5,000 individuals enrolled. At our center, that percentage is closer to 22% African American or Black. But if we look at our data from American Indian or Alaska Native, we have a total of 262 out of close to 43,000 individuals who self-identify as Native American. That's less than 1%. Of note, 61% of that 262 came from our center. So we are emerging as a center that has been particularly successful at engaging and recruiting American Indians into Alzheimer's disease research. And I get asked the question quite frequently about how we do this. How are we able to recruit these numbers of American Indians or African Americans? Next slide, please. We do this by engaging the communities. So much of the funding that we've established for our center, we're able to turn towards programs. We have exercise programs, a computer education program, and we also, in partnership with the Wisconsin Partnership Program, we're able to provide education in tribal communities throughout the state. So in other words, we employ the Wisconsin idea, and we move out of the university out into the community. And by doing so, we establish partnerships, and it's through those partnerships that we're really able to fully engage communities that are traditionally underrepresented in Alzheimer's disease research. Next slide, please. We've had to pivot during the pandemic, understandably. These are pictures from an event from last Saturday last month when we delivered food in a gift bag to our participants. It was a way to again remind our participants how grateful we are for their engagement in research and that we see them as true partners and not just bodies from which we collect data. So these types of events help us keep engaged or help keep connected to our communities. And the idea too is that we get out of the university, out into the community. We've sought funding and we're successful in obtaining funding to collect blood in community locations. Incredibly important during a pandemic. As we think about coming to the hospital, sometimes it makes people nervous to come into a setting like that. So the idea is to collect blood out in community locations, make it more comfortable and easier access. The idea is that we can potentially democratize Alzheimer's disease research. Moreover, it gives us an opportunity to collect blood for blood-based biomarkers, again, trying to move the research out of the university and out into the community. Next slide, please. So I just close with a slide that kind of highlights how we compare to other groups doing this type of work. So these are data from our African American participants only. So of our individuals who have undergone MRI, we have 140 African Americans who have had an MRI in our center. This is right on track when we look at the published studies that are out there. We are close to, we're right in the middle of the pack in terms of the number of MRI data that we have. Our Alzheimer's disease biomarker data, this includes the tau and amyloid scans described by Dr. Johnson earlier. We've had 35 African Americans who have undergone these scans. They're brand new, so we fully expect to be on track to be in line with other centers that are collecting these data. Same is true for our CSF biomarkers. And again, this is CSF biomarkers are collected through the lumbar puncture. We've had 61 African American participants agree to and participate in CSF collection. Incredibly grateful for those volunteers. But then I now turn to look at our blood-based biomarkers. So we've collected blood currently from 325 African Americans. And as we move to the community, I certainly see that number growing. If we are able to analyze those blood-based biomarkers, if we obtain the funding for this, we can be a true leader in our blood-based biomarker data collection. And again, be out in front in terms of democratizing Alzheimer's disease research to achieve better and equitable science. Next slide, please. This is not something done by one person. This is done by a team, and I'm so proud of our team. We have one of the most diverse clinical labs here at the university. We have both diversity in age as well as race and ethnicity, and I'm incredibly grateful to be part of such a vibrant and exciting group. Thank you.
Wow. Well, thank you so much, Carrie. That's really important work that you're doing. Meanwhile, our audience has been doing really important work as well, sending in a bunch of really insightful questions. And to start off, I'd like to pose a question that multiple viewers sent in to us this evening. And Sanjay, maybe you can take the first stab at it. Others might want to join in. But this is a series of questions related to family history, which has been referred to a number of times. What exactly is the connection? How can we begin to quantify an increased risk if one parent or two parents suffered from the disease? And if you do have a family history of Alzheimer's disease in one or both parents, any recommendations in terms of early screenings?
Yeah. Thank you very much. That's such an important question. In fact, our ADRC was among the first centers in the country to look at the issue of family history and the risk for Alzheimer's disease. In general, if you look at the published studies, it is true, it is assumed that actually a family history, especially if one of your parents has the disease, does increase the risk for Alzheimer's disease. The field believes that perhaps the risk is increased in the range of 20 to 30%. So my own father had the disease and he died from the disease. So for me, the risk is increased by about 20 or 30%. Some findings from our ADRC that Dr. Sterling Johnson led initially did show that if one of your parents has the disease, then the risk for Alzheimer's does increase. However, these data need further confirmation and those studies are ongoing. But in general, yes, family history is an important risk factor for Alzheimer's disease. But much can be done to prevent that risk. You heard of all the measures one can take, the healthy lifestyle, the treatment of some coexisting diseases like heart disease, high blood pressure, diabetes. If one addresses those risk factors, you can certainly reduce the risk that you may have inherited from your family. In terms of screening, I think as we have more measures that come along, especially the blood-based biomarkers, as they become available, I think it'll be better for people with a strong family history, perhaps one parent or both parents, or generations of families with the disease might consider getting some screening done. Thank you.
Thanks, Sanjay. Boy, a bunch of questions rolling in here. Here's one that I'd like to direct towards Sterling. Following up on your discussion about how the characteristic plaques and tangles are seen through autopsy, what evidence of disease are you specifically looking for in the spinal fluid and now in the blood tests? And how close is the science in making the blood tests widely available in place of current spinal fluid tap, especially potential availability as a diagnostic screening test?
That's a great question. It's actually the same proteins that we see in the spinal fluid that can be detected in the blood. And the name of the protein is A beta 42. And the other protein that we detect is called tau, or p-tau, phosphorylated tau. And these are detectable in the blood. It's at a more subtle level than we can see in the spinal fluid. There's a much clearer signal in the spinal fluid than what we see in blood. But the techniques are being refined. The tests are becoming more sensitive in the blood, and it's a fast-paced field. It's not quite ready to roll out to the clinic. It's still very much being used in research, and one of the ways we can prove that the blood test would work is by looking at the blood in the same people that we know have some amyloid and tau status, like we do the images and determine whether they have amyloid and tau in their brain or not, or do the spinal fluid collection and determine if amyloid is present or not, and then compare that to the levels we see in the blood. That's the way of cross-validating it and understanding if that blood test is going to work. So that's really where the field is at. We're still in development of these tests, but the signs so far look really promising.
Great. Cindy, I know you're also involved in this area. Anything you'd like to add?
Yeah, again, in addition to the blood tests being really close, I think one great partnership with our clinic network, again, these 40 sites throughout the state, gives us a chance to see how do the clinicians respond to these blood tests. So that's our next phase, is to be able to see, let's get these blood tests out into the community in a research setting to start with, and see what the clinicians think about how helpful is it to them and to their patients in making a good diagnosis out throughout the state.
Great. You know, Carrie, this seems very related to your presentation. Any comments about the need to be inclusive in developing these diagnostic tests?
Yes, thank you. The few studies that have published samples where there's a good representation from African Americans show that there were some key differences in levels of these biomarker proteins, in particular the levels of tau. So it highlights the importance of making sure that we have inclusive groups in our development of these tests. So there's a long way to go in terms of making sure that African Americans are included in the data collection, as well as American Indians and other groups that are traditionally underrepresented in this type of research.
Great. Well, here's a real timely one and a pretty tough one. During the past few months, we've all had to change our contact with our friends and with our family. For families coping with Alzheimer's, could you talk about the relative value and the relative risk of maintaining human contact with a loved one suffering from the disease during this time of COVID? Anyone like to take that one on?
Yeah, this is a very, very challenging time for families across the board. Again, I think we recognize that persons with dementia, as they progress, their world gets smaller, and they really cling to people who they recognize and are familiar with. And so to lose that opportunity, especially if someone's in an institution, which may be closed to outside visitors, does impact the individual with a disease, and we found really impacts caregivers. So we do research on caregivers as well, and have a care research core to try to address these issues. But again, we know that there's a loss through not being able to have contact with people. What the best way is to manage that. Again, some families use Zoom, but some patients with dementia can't understand that that's their family member on the screen, so may need to depend on the aides at the nursing home or care facility where they are. But again, some people are still at home, and so supporting those caregivers is really important so they can be there for that person with dementia.
Great. Here's a question for you, Sterling. It's also very timely as we're seeing a kind of return to football. Is there any correlation between Alzheimer's disease and chronic traumatic encephalopathy, either at the pathological stage of what you would see in brain imaging or at autopsy, or is there any clinical relationship of an interplay between repetitive head trauma and the later development of Alzheimer's disease?
This is a great question. This idea of chronic traumatic encephalopathy, or CTE, is what Dean Golden just described, this repetitive trauma that eventually results in a clinical syndrome of memory impairment, and in some people, it results in dementia. It's as far as the pathology goes, it's related to a different type of tau protein that these current tau images that we have don't detect. So it's a slightly different form of tau, and it's not the form that is specific to Alzheimer's disease. And so another part of that question is, does CTE lead to Alzheimer's disease? It likely does not lead to Alzheimer's. Now, it's certainly possible to coexist, but CTE is its own form of pathology that is separate from Alzheimer's. It's a similar type of protein clumping that happens, but it's a different protein and produces a similar clinical syndrome. So it can be kind of tough to differentiate clinically. The imaging that we do, once that becomes something that can be done in clinical practice, that would be one way of differentiating between those two diseases.
Thanks. Here's a question for any one of a number of you. How is it going now in terms of recruiting study participants with all that's happening with the COVID pandemic? And how can people learn about signing up to participate in these registry longitudinal studies?
Maybe I could take this question. Thank you for this question. It's such an important, timely area to discuss. So some of you may know that as the pandemic started, we had to stop all the research studies until we found out safe ways to start the studies. So in fact, our studies have just started again. We are collecting research data on our participants, partly through telephone calls, and we can actually administer a number of tests through telephone, which is a great development. And some of our participants have agreed to come to the hospital. We follow all the guidelines, CDC guidelines, to make sure that everyone is safe, the participants are safe, the staff are safe, and they come to the hospital and provide some data. I think the significance of doing research, even during the pandemic, is very high. We still need to continue collecting data and learning this disease. One of the areas of research here at UW is how COVID-19 may affect people with dementia and how it may affect cognition or other functions of the brain. I think that's another area that needs to be looked at in detail. Thank you.
Great. Carrie, you might want to comment on that also, but there's a specific question for you. I had mentioned in the intro about your big national award for establishing the first dementia-friendly VA hospital in our country. Could you say something about what does it mean to be a dementia-friendly facility, and to talk about any interplay between all that you're doing and that the whole program is doing at the VA and any intersection with the university hospital that it's connected to.
Certainly. If I may just briefly add to Dr. Asthana's comments about recruitment, where we're following a motto in our center that the safety comes first before the science. And so we've had to pivot, understandably. And we've emphasized that all procedures, of course, be done safely, and when possible, done by telephone. And this is especially true when we're working with underrepresented groups, because as we know, there are groups that are at higher risk for COVID and for higher risk for complications associated with COVID. So our Black participants, our American Indian participants, we certainly are prioritizing trying to do as much as possible by telephone or no contact. And when possible, to move data collection out of cramped quarters and to make the environment for data collection as safe as possible. This is very much on our mind. The people are making great sacrifices to be part of our research. It shouldn't have to endanger their health. So to very briefly talk about what we're doing with Dementia Friendly, I want to just give a shout out to Dr. Mary Wyman, who really was the shepherd for this process and really led the efforts. Dementia Friendly in many ways is good customer service, and following good customer service principles is important for research as well, in terms of understanding that people are, when they come to these centers, they oftentimes come with a level of wariness or discomfort, and we are to, our job as clinicians, as researchers, and as being the face of these organizations is to make sure that people are comfortable, that they're heard, that they're listened to and understood. A lot of this involves training staff as well as changing environment so that signage is easy to understand, for example, that people understand about communication strategies with dementia patients or with people who have cognitive impairments of any kind. So I think I'll leave it at that just to make sure that we have time for other questions.
Great. Well, we are coming close to being out of time, so I'd like to wrap up with one closing question that I'd like to invite each of you to respond to briefly. And this is a great question, okay? As we mentioned in introducing the program, one of the goals of this whole series is to share hope with our patients and families based on the exciting research that's going on here at UW. So here's the question for each of you. What makes you most optimistic about the future of research and treatment for Alzheimer's disease? Why don't we start and go in the order of the presentation, starting with you, Sanjay?
Yeah, thank you very much for that question. So I think most of us know that in the past 2 or 3 decades, the amount of research that has happened in the field of Alzheimer's and the new information we have learned, we truly much better understand what causes the disease. Dr. Johnson mentioned it takes about 20 years before one sees the symptoms of disease. So with all research here and across the country and beyond, now we have some special brain scans that can actually pick up people who may have no symptoms but have the abnormal proteins in the brain. We also know certain measures that one can use if they have these abnormal proteins, the healthy lifestyle, regular exercise, getting a vascular disease treated effectively. These all can really reduce the risk for Alzheimer's disease. And in the form of treatment, as Dr. Johnson mentioned, one of the newly investigated drug, aducanumab, may be close to approval. We are cautiously optimistic. So just in the past 20 or 30 years, we have learned a lot more what causes Alzheimer's disease, what are the risk factors that are modifiable, and there's a real hope that we'll have some effective treatments and also new blood tests to diagnose the disease. So
great. Okay.
Optimistic.
That's wonderful. Sterling, one sentence. What makes you most optimistic?
I want to give a shout out to our participants. They are what drives this engine and makes all this happen. And they inspire me to do this work every day. And so that's what makes me optimistic about this kind of research is our research participants.
Great. Tough sentence to follow, but Cindy, give it your best shot.
Again, I'm optimistic that we have an Alzheimer's drug in the pipeline that has promise against amyloid, and that we have other things we can do right now to improve our brain health, protect our brain health. So I'm excited about that. I think we're moving in the right direction and are close to some breakthroughs.
Great. Carrie?
So what makes me optimistic is the same thing that makes me love my job, is my interaction with participants who are absolutely passionate about finding a cure. And it takes that partnership.
Wonderful. Well, I want to thank our panelists. I've really enjoyed this evening, but I also want to thank our audience. These have been wonderful questions, and I appreciate your partnering with this amazing dream team of researchers for this evening's event. I hope everybody's enjoyed this as much as I have, and that you'll continue to join us. In fact, here's a brief infomercial. Our next Wisconsin Medicine program is on September 29th, and it will focus on the future of medicine. So until then, stay well and on Wisconsin. Thanks.